All right. For our final presentation of the day, we have Dan Russell from Pennsylvania State University here to talk about torpedo bats, their interesting shape, and how they might be affecting baseball.
All right, thank you. So on opening day of baseball, Major League Baseball season 2025, the first 3 games of the season, the New York Yankees were playing the Milwaukee Brewers in the Brewer Stadium, and the New York franchise set a franchise record of 36 runs in the first 3 games. In Game 2 on Saturday, May 28th, the Yankees tied a franchise record of 9 home runs in one single game, and 5 of those home runs came from 5 separate players who were swinging a new style bat that had not been seen in the Major League Baseball before. So I've got pictures of Paul Goldschmidt, Cody Bellinger. I'm going to show you their 2 bats. The one that really attracted attention was Jazz Chisholm's bat. He's the guy on the right. His bat had a different color than most bats do, and so his bat and color and shape really attracted a lot of attention, and the media went nuts. We were getting phone calls and interviews trying to figure out what is with these new illegal, are they illegal? Are they legal? Are they super bats? Do they hit the balls faster? What's going on? So I've got a colleague, Alan Nathan at the University of Illinois. He's retired. I've got another colleague at Washington State University. His name is Lloyd Smith, and the 3 of us have been studying baseball bats and the physics and acoustics of baseball bats since early 2000s, almost 25 years. So the 3 of us have been getting together, and we are currently in the process of trying to figure out what is the actual physics difference. Is there an advantage of these newfangled torpedo bats? So first question is, what is a torpedo bat? Okay, I don't know exactly where the name torpedo bat came from. Originally, when they were first showed up, we started calling them bowling pin bats because they kind of look like a long bowling pin. The idea is a traditional baseball bat, the largest diameter tends to be at the very end of the barrel. So on the left-hand side is the knob. The knob and the handle are very thin, and the bat gradually tapers and gets larger and larger and larger until on the right-hand side is the largest diameter. That's the typical shape and profile of almost all Major League Baseball bats, that the largest diameter is at the very tip. But you hit the ball about 6 inches in from the end. So you're not hitting the ball where the maximum diameter is. So our torpedo bat simply changes the shape and puts that largest barrel diameter right where you tend to hit the ball in the sweet spot. We've known about this for since the 1960s. There was a paper that said that the mass, you want more mass where you're going to hit the ball to be more effective. We've known about the shape of these bats since the early 2000s, and we started looking at the performance of baseball and bat-ball interaction. 2019, there was actually a picture of a torpedo bat in the Science of Baseball book by a guy named Terry Bayhill, but it wasn't until 2025 that they actually showed up in baseball. There was a physicist by the name of Aaron Lienhardt. He used to be a professor of physics at the University of Michigan. I guess he decided he didn't want tenure, didn't want to teach physics, so he became a baseball coach for a couple of small colleges, worked his way up into the minor leagues, ended up as a coach on the Yankees staff, and then started talking to baseball players about let's design the bats to hit well. So what I'm interested in this part of the study is, so here's the concept, is you put the most mass in the largest diameter where the bat hits the ball and makes it most effective. So the bigger picture study we're trying to look at is there a performance difference? My contribution to the study is to take a look and see, does the shape profile, diameter profile of the bat, does that affect the way the bat vibrates? I'm an acoustics person, so I want to know about vibration and acoustics. So I'm measuring these bats. We have a little tiny accelerometer that measures vibration and a hammer that you hit the bats with, and it measures force, and you hit them at a whole bunch of points, and if you make all the measurements, you get these movies showing exactly how the bat vibrates. If you've ever seen, they use high-speed cameras in a lot of the playoff games, and you can actually see bats vibrating like when they hit badly. So I study those vibrations and try to see how they affect the behavior. So, for example, this is Paul Goldschmidt's torpedo bat. The picture on the upper left-hand corner shows the bats. I've reversed them from the previous page just because this is the way we tend to show our data, with the barrel on the left and the handle, the knob at the handle on the right. The picture right below the 2 bats shows the extreme. It's a little bit exaggerated in terms of the actual profile. It's not to scale, but it shows the difference in the 2 profiles. So I guess it's a brown color in the bat shows that the handles in these 2 particular bats, Paul Goldschmidt's bats, they were made with exactly the same weight, length, handle, knob is exactly the same. They swing exactly the same from his perspective as a player. We call it moment of inertia. That's what the swing weight is, what they call in the field in the game. So his two bats swing exactly the same. So the only difference is that shape of the barrel. And the regular bat, the brown curve, shows that as you go from the knob on the right to the barrel on the left, the taper gets bigger and bigger and bigger, and the largest diameter is right at the very end. For the Torpedo bat, the largest diameter is about 15 centimeters, about 16 inches from the end. So it gets bigger in the bulge in the hitting spot, and then it tapers off at both sides. So the question was, does this make a difference in performance? And from my side, does it make a difference in the way the bats vibrate? So the pictures on the right-hand side are mode shapes. So I've drawn, it's a kind of a busy plot. I've drawn the 3 bending mode shapes of a bat, and the 2 curves for each mode shape correspond to the extremes of motion. So the bat is flexing and vibrating and going back and forth between those 2 extremes of motion. So the points where there is no vibration at all, we call those nodes, those are points that don't vibrate. If you're holding the bat at that location, you don't feel any vibration at that point. Or in the barrel end on the left, hitting it at that location means you're not exciting the vibration and the bat doesn't vibrate at all. So we define the sweet spot as the location in the barrel between the nodes or the no vibration points for the first 2 bending modes. And if the ball hits there, then nothing happens to the bat. The bat doesn't vibrate. The ball ends up leaving with a bit of a higher exit velocity. So top picture is the regular bat that Paul Goldschmidt swung in 2024, the entire season. The bottom picture is the bat that he swung in 2025. The bats that I have shown in the photographs here, these are not game bats, but they are the exact bats from the manufacturer to the exact specifications that they would have given Paul. So we made sure that we've got exactly the same bats that he was playing in the game. And the differences are very, very small. Surprisingly, maybe there's not that much difference, especially in the knob end on the right-hand side. There's very little differences at all. The big difference is the sweet spot shrinks and moves toward the handle about ½ an inch. Maybe significant, maybe not. But that's really the only difference between those 2 patterns, at least for this bat, is that the sweet spot moves about ½ an inch closer toward the handle. Bellinger's bats are a little bit different. So the bat that he swung, the regular bat on the top of the picture and the Torpedo bat on the lower picture, his barrel never actually achieved the maximum allowed size by a major league in his old bat. The new bat with the Torpedo shape actually has a larger diameter barrel, the largest that Major League Baseball allows, and it's got the Torpedo shape. His handle knobs are very different as well. And his bats also in the knob region, there's a little bit of a difference in the amplitude of vibration because the knobs are different. The knob end, handle end, node locations where there's no vibration a little different, but in the barrel end where the ball hits the bat, there's not much except that the sweet spot is a little bit narrow and moves about ½ an inch closer to the end. So not a big change, not significant. For me, I'd be lucky if I can hit the ball, but these players who can hit ½ an inch makes a difference. And the fact that you're hitting it at a point where there's a larger diameter might mean that there's better performance. So this bigger study that we're doing, we're actually going to be presenting the results of our other. So I do the vibration testing. Alan Nathan from Illinois does the computer modeling, and then Lloyd Smith in Washington does. We put in balls in cannons and fire them at 160 miles at these bats, and the bats swing, and we measure the bat ball coefficient of restitution, which tells us the elastic interaction, and we can calculate the exit velocity, the actual batted ball speed for those 2. And the results show or predict that the difference between a regular and a Torpedo bat is not that much. There is no difference in the maximum batted ball speed. The difference is the sweet spot moves about ½ an inch to an inch to the inside. So a player who tends to hit inside pitches might have a little bit of an advantage, and if you've redesigned the bat to match that player's hitting style, which appears to be the case, then you might have an advantage if you hit inside because you're hitting at a location where the bat is designed to do that. So there is a slight difference, a slight advantage for inside hitters, maybe, which is why we haven't had enough data yet to see if it makes a change in their batting averages or the number of home runs. The media attention just kind of died away after the first couple months because nobody cares. They didn't make that big a deal. Jazz Chisholm no longer uses his Torpedo bat. So you don't see a really big difference in the mode shapes until you go to really extreme shape differences. Okay, so this is a Heine Groh's 1912 potato masher bottle bat versus a bat that has a really big knob. So these bats are very different in shape, and they have, as a result, very different mode shapes, very different node locations that make a big difference. These are not bats currently in play, but the bottom line is that the Torpedo bat really doesn't make that much of a difference because it's not a hugely significant difference in the change. So it got media attention for a while, but not as big of a deal as we were maybe thinking or some people were thinking it was going to do. So thank you.
Bring the media attention back.
Yes.
Well, that was so exciting to hear about. As we wait for the questions to roll in from the live stream, I'll turn it to the room if anyone has a question about torpedo bats for this presentation.
Hi, I apologize in advance, less of a physics question and more of a baseball question. But I'm curious because we're like a couple months into the 2026 season now. Do you know how has the attitude towards torpedo bats changed among players? Is there more adoption? Is there less adoption now a year later?
That's a good question. I don't know how many players have adopted it. There were more players last year who were using them than the media knew about. The Yankees got the attention, but there were players in at least 10 other teams that were using them at the same time, just nobody cared, apparently. Some players that have used them are no longer using them. Baseball is a very superstitious sport, so if there's something that helps you play, you'll be good at it, and if it doesn't help you, you're going to abandon it, try something different. So it definitely was not changing the thing like, there's been changes in college baseball where changing the bats or changing the balls definitely made huge differences in the number of home runs or hits per game. In Major League Baseball, this is maybe a flash in the pan. It makes some players maybe hit more confidently, and if it helps them, we think partly for a professional player, the bulge on the barrel is something they can actually visually see while they're swinging. So maybe it helps them make contact better. I don't know that we've got enough data to compare like batting averages. The reason we specifically looked at Goldschmidt's and Bellinger's bats is we do have from 2025 and 2024 StatCast data showing exit velocity and impact location like for the entire season average. So we can tell the difference in where they were hitting on the barrel, and it does seem to agree with that half an inch shift towards the handle end for the difference in their bats.
Thank you.
Yes, thank you. And we have a question from the live stream. How much does a player have to consciously change their playing style to adapt to a torpedo bat?
I think it depends on the player. In the case of the two players that we've been looking at, or the two bats that we've been looking at, for Paul Goldschmidt, because his bat was designed to have the same swing feel, basically he's not swinging a different bat in the terms of what it feels like, so he's not changing his mechanics. He's just swinging the same way, but his bat is going to maybe have a little more diameter at the point where he's impacting it. In the case of Anthony Volpe, I don't have his bat shown, but they were specifically looking at high-speed video of him, and they designed his bat based on where he was actually hitting the ball. So they weren't telling him to change his swing. They were saying, what is your swing? And let's just modify your bat to take advantage of what you're actually doing. So again, there's a superstition thing. I don't know how much it actually changes a player's attitude to the way they swing. Unless they think it's going to help them do better, then it's probably going to help them do better. Understood. Yeah.
And one last question, just out of curiosity, how many bats do you all have on hand for this research?
We have 4 of each of the players' bats, so 2 pairs of normal and regular bats, just in case they break in the high-speed testing they do. Altogether in my lab, I've got 120 different bats, and the Washington State lab is where they do all of the testing for all of college and Major League Baseball, so they have thousands of bats. And yeah, so we've got a lot of bats. We're batty in our collection. Yeah.
Thank you so much.
Thank you.